Okay, welcome back. I am going to do a bird's eye view of several topics, and we'll go into them in more depth here in a bit, but I wanted to make certain that I at least provide the superficial view of these things before we get into that deeper thinking. So there's a couple of properties that real numbers have. Not all properties are available for all different kinds of groups. So in certain circumstances, there will be instances, not in this class, but if you were to go on into other classes, there may be circumstances where instead of being able to say A plus B equals B plus A, that would not be a true statement. So it's important to know that there's a reason why we actually specify our different properties. All right, so the commutative property is what it sounds like. It can commute. It can move around within the expression. And there's two different types. One is addition and one is multiplication. And these are the most simple examples of it. I have A plus B equals B plus A, or M times N is the same as N times M. All right, next property is associative. You can work in whatever order, and I got to be real clear here that this only works when you're talking only addition or only multiplication. You can't like mix and match in the middle of things. So you have to make certain that you're dealing with only one of those two operations, and then you can take a look at how it makes the most sense to add things up. So here we have A is being added to the quantity of B plus C, and here A plus B, that quantity, is being added to C. Both of those statements are true. Both of those will actually give you exactly the same number. So it doesn't really matter how you group them in that regard. It might make it easier to group them in a certain way going forward. So sometimes it's easier to say, well, I'm going to do this instead of this. Okay, and we'll dig into that a little further when we get into the deeper thinking. All right, so our M times the quantity of N times O is going to equal the same as M times N, that quantity multiplying O. All right, so here's the one case where we get to have more than one operation happening. And this is called the distributive property. We shortened it up to that because the real name is the distributive property of multiplication over addition. That's quite the mouthful. So rather than saying that every single time we want to convey this idea, we just call it the distributive property. And what's happening here is that we are multiplying our A, in this case, times everything inside the parentheses. And I have had somebody ask me once, why don't you just add that B and the C together? Well, normally your order of operations would ask you to do just that, and that's fine. But sometimes you have like a number and a variable, and we don't know what that variable is, or that's what we're solving for. So sometimes we can't just add these two together. We have to treat them as two separate sets of numbers that we're multiplying A by. Here I have an AB plus AC, and that means I've multiplied my A times the B, and I've multiplied my A times the C. Now, I'm going to caution you, it's real common for people to get the first one or the first two, and if you have more than, that one or two items that you're supposed to be multiplying, oftentimes the last one or the last several get omitted. All right? As I said, though, that is the one time that we have a mix and match with our addition and our multiplication. We also have what's called the identity property. The identity property tells us that we can either add or multiply a certain number, and we get that same number back out. So in the case of A plus 0, or 0 plus A, you get A back out of there. That plus 0 doesn't change anything, so your original value comes back out at the end. Here we have our N times 1, or 1 times n, and that's going to give us n. Again, that gives us our original number n back out. And I want to caution folks, people, for whatever reason, tend to mix things up when you're talking about adding and multiplying. You can't multiply by 0, and you can't add by 1 here. Otherwise, that's not the property that you're talking about. Because any number times 0 is going to give you 0. And if you add 1, it's no longer that original number. So the identity property, be real clear on what it is you're doing, whether you're multiplying or adding, and be sure to use the appropriate piece to show that identity property. All right, so the inverse property is very much related to the identity property. Here we have the a plus 0 gives you the a back out. Here we're saying we want to get to 0, so we have the a, and we're taking the opposite of a, okay? And I want to be real clear. A could be a negative number, and the opposite would then be a positive number. So just because this says a doesn't mean it's intrinsically a positive number. So you're going to have the a and the opposite of a, and you add those two together, and you're going to get a 0. All right, that's pretty straightforward stuff, at least on the surface of it. We also have the goal of getting to our 1, which is our factor that we use for multiplying to get our identity. Here again, we're going to do, we're going to have our number, and we're multiplying. And I want to just back up a second. Here we have 3, and I'm going to put it as 3 over 1. So you could also have this as 6 over 2 or some other variation. So you can see, and 3 is usually the way we write things rather than 3 over 1. But I wanted to make certain that we're aware of that, because what we're going to do is we're going to take the reciprocal, or turn the fraction of the 3 over 1 on its head, so we get a 1/3. We're multiplying those across, and to get a 3 over 3, which is a 1. Now, again, there's reasons we do this. It seems superficial, but certainly when you're dealing with trying to find a common denominator, or other factors that are going to be in common, then you are going to need to be able to use this inverse property. All right, so I'm going to move along to absolute value. And again, I'm giving a bird's eye view. We'll come back to this, and we're going to go into more depth. So absolute value is a distance. It does not matter which direction I go, I travel the same distance. So if I were to go from Minneapolis to St. Paul, and then from St. Paul back to Minneapolis, I've gone that same distance. It doesn't matter which direction I went the same distance each time. So in this case, we wind up saying, how far is -1 from 0? Well, how many units do you have to travel? You have to travel 1. So the absolute value of -1 is 1. And for 0 to go to 1, you have to travel 1 unit. So again, the absolute value of 1 is 1. So it's possible to have two very different numbers have the same absolute value. All right, and we're going to talk more about that here in a moment. We're going to be changing things up in here on the number line so that folks can kind of see what's some of the set notation. And I want to be sure that we're real clear on some of that. All right, so our set notation, this is how we can write things in an abbreviated form, and we can also show it on our number line. So here, if you have a paren, that means it does not include, right? It's not equal to. So it would be strictly greater than or strictly less than. All right. We are going to use a square bracket when it does include. All right. We are including the value. So we would have a less than or equal to, or a greater than or equal to. Now, equal sign is just going to be a dot, but I wanted to make certain that we are all on the same page. It has to have the equals portion for it to be included. All right, so if we don't include -1 or 1, and I want that interval in between them, right? I want to have the interval for the positive and the negative value of 1. For absolute value, I would go from the negative 1, and I'd have a paren because I'm not including the 1. And here I'm going to have the paren on the 1. So that's also saying I'm not including that 1. All right. So here we have, you don't include the negative 1 or 1, and you're looking at that interval. And if you take a look at how this is written, it appears to be a coordinate point. It looks like it should be the point -1, 1. In this case, though, we're talking about a set notation, and that's a context. This is sort of that whole 2, 2, and 2, or there, and there in English. Math has a few of those as well, and this is one of those cases where you have the absolute value and the set notation for that appearing like it's a coordinate point. So you really have to keep in mind the context of what's happening. So if I were to take a look at this next one, it says everything less than -1, including -1. So I'm going to go to the -1. I can take care of anything that was elsewhere. I'm going to remove that. So now I've got my -1. I'm including my 1 or -1. Okay, so I'm going to have a square bracket, and I want everything less than that. So my square bracket is going to face towards the left. All right, it's going to face towards the left because that means I'm headed that direction. So I would really be looking at something that goes this direction from the -1 all the way down, right? And it goes on forever and ever and ever and ever and ever. So that's going to give us a negative infinity. And negative infinity, a lot of people say infinity and whatever. They don't recognize the fact that infinity is a concept rather than an actual number. There is no number infinity. It's the concept that we can just keep going forever in that direction. And in this case, because it's headed towards the left, it's going towards a negative infinity. And you would write this just like this. You'd kind of like draw in. Here, I'll bold this just so that it's clear that we're, there we go. So everything this direction, all right, and keep on going that way. All of that. So from there on, that's going to give us our values. So when we write it in interval notation, we wind up having negative infinity, because that's we're looking from our lowest bound to our upper bound, right? So we read from left to right. So we say negative infinity with a paren on it because it's a concept, not a number. And then we have a comma, and then we take -1, which is our upper bound, and we use a square bracket because that is included. We are including that value. All right, so on to our next one. We want everything greater than 1, including 1. So we're going greater than 1. All right. So in this case, this is my lower bound. This is the lowest it can be is 1. So here I have my square bracket, and it's going to be facing towards the right because we're going larger than, right? And so it's going to go this direction, right? It's going to keep on going that way forever and ever and ever and ever. So when we write it as an interval notation, we have a square bracket, and we have a 1 because we're including the 1, and that's our lower bound. And then we're going to go towards infinity. And again, that's a concept, so we can't actually ever reach it. And everything between -1 and 1 inclusive, well, that's a fancy way for saying we're including both the negative and -1. So -1 and 1 is what I meant to say. Okay, so here I'm going to have my square bracket at the top facing from my 1 facing to the left, and on my negative one, I'm facing to the right. So I'm going to have my square bracket like that. So this is what I'm going to have, and this is how I would document my interval notation in this case. And I think I'm going to stop at this point. In fact, I think that is the end of where I wanted to cover.